Welcome back to lesson 10 in our pre-AP chemistry math section. Temperature conversions. Temperature is an important measurement in chemistry. It measures the energy of motion of molecules. The energy of motion is kinetic energy. Kinema is motion. The cinema was the name that was given to moving pictures because the pictures are moving. They were kinetic cinema. So just a little trivia there. The more kinetic energy molecules have, the more they move and the higher their temperature. In chemistry, temperature is most often measured in units of Celsius or Kelvin. Fahrenheit is rarely used in chemistry. Still, we need to know how to convert Fahrenheit to Celsius and vice versa. If you listen to the previous video, you know how to rearrange this equation, but let's solve a sample problem together. How many degrees Celsius is 98.6 degrees Fahrenheit? So really, I am just going to put this into the equation and solve for Celsius. I always rewrite a variable before I solve for it, but this already is degrees Celsius equals. So I'm just going to plug in my numbers. 5 divided by 9 times 98.6 minus 32. You always do the parentheses first. And it looks like I'm going to need my calculator. Okay, so 98.6 minus 32 equals 66.6 times 5 divided by 9. And I get 37 degrees Celsius. If I were going to use sig figs, this was 3 sig figs, so I want my answer to be in 3 sig figs. So I put the answer as 37.0 degrees Celsius. Now I want you to solve problem number 2. Pause the video, solve it, and then come back to check your answer. Welcome back. Okay, so how many degrees Fahrenheit is the boiling point of water, which is 100 degrees Celsius? They put a decimal down here to tell you that all these digits are significant because trailing zeros are significant if there is a decimal written down there. Okay, so our equation is degrees Celsius equals 5/9 degrees Fahrenheit minus 32. I already showed in the previous lesson how to rewrite this equation to solve for Fahrenheit, but I'm going to do that again right here. The first thing I need to do is I need to get rid of the constant in front of the parentheses because I'm solving for an unknown in parentheses. So I'm going to do the opposite of that. Since it's being multiplied by 5 and divided by 9, I am going to multiply by 9 and divide by 5. And what I do to one side of the equation, I do to the other. So my equation now is 9/5 degrees Celsius equals degrees Fahrenheit minus 32. To finish isolating degrees Fahrenheit, we need to get rid of the minus 32. To do so, we do the opposite. So if 32 is being subtracted from it, we are going to add 32 to one side, to that side, and we're going to do the same thing to the other side. On the right-hand side, it cancels out. I'm going to rewrite the equation with Fahrenheit on the left. Fahrenheit equals 9/5 degrees Celsius plus 32. Now I can input my variable and solve for Fahrenheit. So we have 9/5 times degrees Celsius, which is 100 degrees Celsius plus 32. So we're going to do the multiplication first, 9 divided by 5 times 100. And then we are going to add to that 32. And we get 212 degrees. 3 sig figs, it's to the ones place, so this is 3 sig figs as well. So 100 degrees Celsius, the boiling point of water is 212 degrees Fahrenheit. Now let's learn how to convert between Celsius and Kelvin. This you're going to actually use a lot more than the previous one, but the previous one is just a little practice. Fahrenheit is not used in chemistry, but if you're using English units, you may end up with Fahrenheit at some point. The Celsius temperature scale is built on the freezing and boiling points of water. The freezing point of water is 0 degrees Celsius, and the boiling point of water is 100 degrees Celsius. Any temperature below 0 degrees Celsius, below the freezing point of water, is negative. The Kelvin scale, on the other hand, is built on absolute zero. 0 Kelvin is the lowest temperature possible at which all motion would cease and the world would cease to exist. I'm being dramatic here, but it's true. To convert between Celsius and Kelvin, we use this formula. Kelvin equals degrees Celsius plus 273. It's probably more precise to do 273.15, but that's just gonna take you more time on an AP exam. So 273 is fine. So here they want us to convert the boiling point of water 100 degrees Celsius to Kelvin. Luckily, we have the Kelvin's formula right here, degrees Celsius plus 273. So it's 100 degrees plus 273. So the Kelvin is going to be 373 Kelvin. And by the way, Kelvin is not degrees Kelvin, it's just Kelvin. So that would be our answer. Do not put a degree sign for Kelvin. Here is a practice problem for you to do. I want you to pause the video, solve this problem, and then come back. Welcome back. Convert absolute zero to degrees Celsius. So let's get our equation again. By the way, absolute zero is 0 Kelvin. Our equation is Kelvin equals degrees Celsius plus 273. If I want to solve for Celsius, I want to isolate that variable. Right now, Celsius on the right-hand side is 273 is being added to it. So to isolate this variable, I need to remove 273 from this side. So I'm going to subtract it. And what I do to one side, I do to the other. So I'm just going to minus 273. So my equation becomes degrees Celsius equals Kelvin minus 273, which in this case, we're talking about 0 Kelvin minus 273. So it would be negative 273. And we do include a degrees Celsius. I see I have a mistake here. Let's fix that. We do include a degree sign for Celsius. Okay, that's all I have for temperature conversions. If you want more practice with this, I believe I do have a worksheet uploaded where you can get more practice on converting measurements. And then meet me back in the next lesson.